Hey, this is Emma Jakob and Courtney Brown, and this is homework 3 for Engineering 460. Problem 3 describes a scenario where a machine tool has a part that has to be scrapped. Well, basically the machine has to be scrapped 4 years from now, and you have two different options with the machine itself. The machine contains a part that has to be replaced. You can either replace the machine part every time it fails, or you can replace the machine part every time it fails for the first 2 years and then go on a preventative maintenance plan for the next 2 years. Now, the time to failure for the part is modeled by the time to fail density of x times e to the negative x on supports from 0 to infinity. So assuming that replacements are instantaneous and it costs CF pounds on failure and CP pounds on preventative basis, simulate 5,000 realizations of 4 years for each policy and find a condition of the cost of preventative over the cost of failure for preventative replacement to be a preferred option.
So in order to find that condition where the preventative replacement plan is to be preferred, we're actually going to look for a ratio with CP divided by CF, so the prevention one divided by the failure plan. And so in our code, we're basically comparing the two different policies here. And so we're generating random numbers R1 and R2, and we were given the time to failure density back on this slide right here. So it's f of x equals x times e to the negative x. And so we're going to have x be the negative log of those two random numbers, and that's based off of that time to failure density that we were given. And so then we are running those through and we're simulating it with 5,000 iterations. And so we're looking at the number of failures in both of them. And so after the first one, we're going to get the mean of those failures by dividing our number of failures for the first policy by the iterations. And in the second one, we're doing the same exact thing here, just with comparing it to 2 years. And then for that mean, we have to times it by 2 because we're looking at 2 separate time periods. So we do that before we get the mean. And then this last part of code here is just the little algebra of finding that ratio. So we see that the mean of the first policy is around 1.7, whereas the mean of the second one with the number of failures is 1.5. And so that ratio is actually going to be about 0.22. And so the prevention plan is 1/5 of the failure plan. So that's going to be our preferred option there.